Hi, so in the previous video we talked about some formulas and now we're going to use those formulas. And also negative 34, it should be negative 34 joules instead of negative 24, which I said in the previous video, I think. So, alright, so here's the question. If light has a frequency of this, find the wavelength, energy, and type of light. Okay, so let's first use our formula of C equals wavelength times frequency. So C is 3.0 times 10 to the 8th, and frequency, which is V, we're looking for the wavelength. So this times V, so 5.371 times 10 to the 14th. And no, all frequency, the label will be Hz. All wavelength, the label will be Nm. All energy, the label will be joules. Okay, now let's continue. We're going to use our calculator and do 3.0 e to the 8 divided by 5.371 e to the 14th. And that gives us 5.58555 times 10 to the negative 7. I take back what I said in the beginning. This is in meters because we use meters per second over here. Meters. So, alright, here's the thing. Frequency is Hz. Wavelength is not always nanometers. Energy is always joules. Here, take that. When you're using the light formula, it's meters because it's 3.0 times 10 to the 8 meters per second, not nanometers per second. Okay, now we have this, and now we found the wavelength. Now we gotta find the energy, right? Cut all of that. God. Okay, now that we found the wavelength, it's time for us to find the energy. Energy is equal to, let's see, H 6.6262 times 10 to negative 34 times frequency. We found the wavelength, but we don't need that. It gave us a frequency already, so we're going to use that. 5.371 times 10 to the 14th Hz. So 6.6262 e to negative 34 times 5.371 e to the positive 14th, and that gives us E is equal to 3.5589 times 10 to the negative 19 joules. And remember to use rule of 3. So this will actually be 5.59. This will be 3.56 here. Now finally, we found wavelength, we found energy. Now we're going to find type of light. So we go to wavelength, 5.59 times 10 to the negative 7 meters. 1 meter consists of, 1 meter contains 10 to the negative 9 nanometers. So 5.59 e to the negative 7, 10 to the positive 9, times e to the 9th. Okay, that gives us 559 nanometers. Okay, now we got our hydrogen Bohr model and electromagnetic spectrum. So this is Nm. Alright, so 559, where does that land? 559, oh wait, shoot, I didn't even need to do this. It's in meters. Oh, we just did an extra step. That's okay. So we have this much meters, 5.59 times negative 7 times. So 5.59 is in between 4.9 and 5.7. So this light will be green light. And then to be more specific, it will be green visible light. And I found that by looking on the electromagnetic spectrum and hydrogen Bohr model. So 500, oh actually we didn't do this to find 559 Nm on the hydrogen Bohr model. 559 sits in the visible section. And if we look down there at 5.59 times negative 7 meters, 5.59 belongs in between 5.7 and 4.9. So the color in between that is green. So this is how we found the answer to wavelength, energy, and type of light using hydrogen Bohr models, hydrogen boron model, electromagnetic spectrum, and our two formulas. Thank you for watching.